Okay, we are already in last part of this chapter for, the last part of session 1. Nutrient requirement, if you see in the graph, we have relative plant growth and concentration of essential elements against concentration of essential elements. Sometimes in exams they come out with this graph. They ask you to explain the graph. 9 or 10 marks. It's very easy actually. So when you have to communicate, or you have to collaborate or merge the idea with X and Y. What you can see in the Y is concentration of essential elements. If the essential elements are the nutrient, we talk the nutrient is very low, by a bit of a moderate amount or good amount, very high nutrient level, and very extremely high nutrient levels. This is the plant growth. If very low nutrient, the plant growth is stunted. If you have a low nutrient level, the plant still can grow, but it's not to the optimum level. When you have good amount of nutrient or essential elements, the plant growth as optimum level. But if the nutrient level is high, is essential very high, it will become toxic, and the plant growth will be less again. The plant, if the plant is toxic, sometimes the plant will not flower, produce flowers. The yield or bunches or the fruits will be low quality or small in size. Toxicity, because the toxicity overtake the optimum level of plant growth, so it will be reduce, and when you have excess of elements, again the plant will show the same symptom as lower level of elements. At last it will be die. If you have extreme, very extreme, it will be very toxic, high in acidic, so the plant will die, wilted, die. So very simple explanation. 2 marks when you collaborate, when you explain using the keywords: deficiency, optimal, toxicity, extreme, extremely low plant growth, mild plant growth, optimal plant growth, mild and extreme again, and you explain this thing, you can get easily 9 to 10 marks or maximum marks. These two are the same picture, just there's another graphic terms and the graphic way. Throughout my class, I will talk about 4R and site-specific management. 4R principle for sustainable farming. You need to apply to the right source of fertilizer. Right source here means this one. When we see the nitrogen ions, right? Ions, yes. These are the sources. We need to understand the plant and also the surface of the soil, where the soil, like paddy. In paddy fields, the waters will be there, stay there. When the water stay there, you cannot apply ammonia. You need to apply nitrogen oxide. So this is what explained here. We need to apply the right source of fertilizer at the right rate. At the right rate, you cannot have apply the very low level. You cannot apply the fertilizer at high level. So this is touch. For the right rate is touch this for this graph. Right timing. When you plant a seed, you straight away cannot apply NPK and Mg. That one will encourage flowering, so your plant will be lacking of nitrogen. So the plant will be short, very short. And also need to apply at the right place. You just remember where we apply NPK and where we apply our MOP. MOP in between the plants, in between the coconut trees, while NPK we do circle fertilizer application. That means sekeliling batang pokok. While our MOP, muriate of potassium, we apply in between the leaf. Not MOP, we apply MOP. The red color fertilizer that we apply. So class, if you have any questions, you can contact me anytime, or you can ask, you can write comments below the video as well. Just text me, or when we meet in our class, please do ask questions. This is how we communicate, interact, two-way interaction will happen. So that's all for now. So in our next slide will be fertilizer. We talk about fertilizer. We already did it in our lab actually. So that session will be more or less, I will ask questions, you answer. Thank you, students. Thank you, class. Bye. Have a nice day.